I'm here to talk about routing information protocol. Routing information protocol is one of the dynamic routing protocols that route packet, looking at the best direction or best path to the remote network. And that is why it is considered as a distance vector routing protocol. Okay? It has administrative distance of 120. Okay? It has a maximum hop count of 15, and the 16th one is considered destination unreachable or root poison. Hop count is from here to here, from this network here to this network is one hop count. From this network again to this network is another hop count, making 2, which means PCO or PC0 is 2 hop count away from PC2. Okay? Like I said before, it has administrative distance of 120. Administrative distance is a kind of a way to recognize or trust a routing information protocol received on a one link. Okay, so the lower administrative distance, the more trust a link or a router will trust a kind of a routing information received on each one interface. Routing information protocol exchanges route information or routing update using the entire routing table to its directly connected network. For instance, if this router wants to exchange a routing information with this router here, it will send the entire routing protocol to this router. Routing information update or advertisement is a kind of, that is what routers use to update each other on how or the state of the network. As I said, RIPE exchanging route update using entire routing protocol to the neighbor router. A kind of, this is my route, these are the what I have in my routing table. A kind of routing update. The exchanges routing update. Let's say this LAN here goes down, and every 30 seconds the exchanges route information, routing information or routing update. If this link here, this one LAN here, LAN interface goes down, this router will use the entire routing table to send to this router. And remember, this router has been receiving this LAN, this route in its routing, in a kind of route update from router 0. So when this link goes down, after 30 seconds, when router 0 send route update, it will exclude this, and router 1 we know that so this your LAN route or interface is down. Now this router will now update this router 2 that the LAN interface of router 0 is down, and whenever it comes up, same thing will happen. So let's configure routing in our network. Let's configure it. This is router 0. Okay, yeah, we are going to add all these networks, all these address spaces. Okay, router RIPE, you have enabled routing, you know, network 192.168.10.0. You hit enter, press your arrow key to give you that again. 20, you just edit 20.0, press your arrow key to bring it back. 30.0. Let's add our one link, network 172.168.10.0. One link is subnetted to, press your arrow key and put 4. No, version 2, no auto summary. Done with router 0. Okay, let's go to router 1. Router 1, let's maximize it. Okay, enable, configure terminal, router RIPE, network 192.168.10.0. hit your arrow key and edit to 20.0. hit your arrow key again and edit to 30.0. add the one link 172.168.10.0. hit your arrow key. Okay, what happened? Network 172.168.10.0. okay, hit your arrow key and put 4. okay, version 2, no auto summary. Okay, so let's go here. Auto summarization is when you configure, you know, like RIPE version 1 that, you know, lends a classful IP address. You know, this RIPE version 2 can, you know, hold different subnet mask, you know, can configure the net address spaces of different subnet mask. But while RIPE version 1, you know, learn routing information like root on its routing table with a classful IP address. Okay, router RIPE, network 192.168.10.0. hit your arrow key and edit to 20.0, or you can still say network 192.168.30.0. you know, network 172.168.10.0. hit the arrow key and put version 2, no auto summary. We are done with RIPE configuration. Let's do show IP root. You can see root have learned. This is the last router, router 2. You can see the LAN interface of router 0. You can see the IP address in this routing table that was learned through this, you know, link here. Let me show you. Look at this IP address here is in this routing table. This router 2 has it in its routing table for communication. Without it, this communication from here to here will not be successful. And it was learned from this interface. This interface here, you know, this number 5 IP address. Let's number it. This 1, this 2, you know, this 5, this is 6. Okay, remember it's subnetted to. Okay, these two IP addresses are from this address space. Look at this address space so that you will know what I'm talking. This address space is 30 bits. Okay, the first usable IP address here after this 0 is 1. the second one is 2, and that is what 30 bit of subnet mask can give you, 2 IP addresses. The next, block size is 4. Look at it here. And the first usable IP address that after 4 is 5. The last one is 6. So you can see that is how I've really taught you people this before. So now you can see that the information, every router, all these addresses, this one link and these are in this router 2's routing table. Okay, and it was learned from this link on this address. Whatever that is packet that is sending from PC2 to PC0 will be sent to this link here. Okay, so let's check router O's routing table. Okay, show IP route. You can see route. Come on, see it here. See the last router, which is router 2 IP address, was learned on this link. Okay, look at the router 1, which is the middle router. This is the LAN address. Okay, look at their, anywhere you see R means the root of that, the other network that is in the routing table. And remember, this is routing information protocol, RIP. Yes, it shows R, meaning RIP was configured. But this R also means that anywhere you see R is the other network address. Do you understand? It has learned the other network address in its routing table. Like this one now, this is its own address. Look at it. Local link and link connected, directly connected. You can see it. So look at the second one. I told you about 4. Look at it. The 4, the second subnet, which has block size of 4. Look at it here, and which is this network here, this link here. Okay, so that is how root works. It sends this route. Look at this, 1 2 3. When this router wants to exchange routing update or route update with this router, it will send that route to this router, informing that these routes are still in my routing table. There is no problem. What about you? Let's say this link is done. This one will now inform this that router 2 link is done. So router 2 will now know that, oh, so that link is done, and this happens every 30 seconds. Now let's ping from this here to this. Okay, let's ping. You see that there will be communication. Okay, you see that there will be communication. Let's open it. Okay, the link is open. Mean the system PC0 is open. So let's ping that address. Ping 192.168.30.2. Okay, one timeout, meaning app, address resolution protocol. Look at it, is successful. So if you find this video interesting, do not hesitate to share it. Thank you, and see you in the next video.